When you look at a construction site, what do you see? Probably just a bunch of big machines moving dirt around, right? But what you're actually looking at is a super precise engineering discipline. Today, we're going to decode the secret language they use to sculpt the earth with incredible accuracy. Let's dive in. I mean, think about it. It's a huge challenge. The ground is naturally bumpy, full of dips and rises. So how on earth do crews create a perfectly flat foundation or a parking lot that drains just right over a massive area? Well, the answer is way more elegant than you might think. So here's the game plan. We'll start with this idea of an invisible ceiling, which is the single source of truth for the whole site. Then we'll lock in our permanent save point and calculate the all-important God line. After that, we'll see how to turn all that math into moving actual dirt, make water go where we want it to, and we'll wrap it all up with what's called the Academy standard. All right, first things first, we need to get our heads around the basic tool that makes all of this possible. It's all about creating one undisputed reference point that everyone on the job site can trust. And this is it. This is the big secret. A rotating laser level, it doesn't just shoot a little red dot. No, it spins so fast that it creates a continuous, perfectly level plane of light. Basically an invisible ceiling that stretches over the entire project. This plane of light becomes the single source of truth that every single measurement is based on. And this quote from the Excavation Academy just nails the mindset. This isn't about brute force, it's about precision. Like it says, they're not just digging holes, they are literally engineering the ground itself. And that whole process has to start with an absolutely reliable reference point. Okay, so we've got this invisible ceiling, but a ceiling floating in space isn't much use, right? We need to know exactly how high it is relative to the ground. And to do that, we need a permanent, unmoving anchor. And that anchor is called the benchmark. Honestly, the best way to think about it is as your permanent save point, just like in a video game. It could be anything, really. A surveyor's pen they hammered into the ground, a specific bolt on a fire hydrant, anything that has a known elevation, and most importantly, is not going to move. Now, on the site plans, this benchmark will be assigned a very specific elevation. And a lot of the time, just to keep things clean, they'll use a nice round number like 100.000 meters. But don't let the simple number fool you. This isn't random. It's the official starting point for every single calculation that's about to happen. It all starts right here. All right, now we're getting to what is maybe the single most critical calculation on any job site. This is the moment we connect our save point on the ground to that invisible ceiling we've been talking about, floating up in the air. This number is called the height of instrument, or just HI for short. And what is it? It is the exact elevation of that spinning laser beam. Once you figure out this one number, it becomes the master reference for, and I mean everything that happens next. Every trench, every foundation, every pipe. And to really hammer home just how important this is, the folks at the Excavation Academy, well, they have a nickname for it. They call it God on Site. Seriously, because once that HI is established, it is the absolute unquestionable authority on elevation. It rules everything. No arguments. So how do you find this all-powerful number? Well, it's actually incredibly straightforward. First, you take a measuring stick, it's called a grade rod, and you place it right on top of your benchmark. Then you slide a little laser receiver up or down that rod until it starts beeping like crazy. That beep tells you found the laser beam. And then you just read the number on the rod. That's it. And the math behind it, it's just simple addition. You take the known elevation of your benchmark, you add the measurement you just read on the rod, and boom, that gives you your height of instrument. So let's just walk through our example here. We start with our benchmark, which we already know is at 100,000 meters. The receiver beeped when it read 1.50 meters on our rod. So we just add those two numbers together. And we get 101.50 meters. That is your HI. Your God line is now officially floating in the air at exactly 101.50 meters. From this moment on, every single measurement on this site will be taken down from this one invisible line. Okay, pretty cool, right? We have our all-powerful HI number. So now, how do we translate that one number into actually digging a trench or pouring a footing? This is where the theory becomes reality. And guess what? The formula is just as simple. You take your height of instrument and you just subtract whatever final elevation you need to hit from the building plans. The answer tells you exactly what measurement your rod needs to read when you're at the perfect depth. Look at how this works. Our HI, our God line, is always 101.50 meters. It doesn't change. So if the plans say a manhole needs to be at an elevation of 99.50, we subtract that from our HI and our target rod reading is 2.00 meters. For a deeper footing at 98.00, our target is 3.50 meters. It's always the same HI, just a different target depth. The operator knows to just keep digging until their receiver beeps at that specific number. No guesswork. But hang on, so far, all we've talked about is making things perfectly flat. What about when you don't want a flat surface? What about something really important, like drainage? This is where the tech gets even cooler. And this brings us to a fundamental piece of wisdom from the field. It's just simple physics, right? If you build a parking lot or a sidewalk perfectly flat, you've just built a pond. You have to engineer a slope to tell the water exactly where you want it to go. Now, back in the day, creating a consistent slope was a nightmare of constant math. But with a modern dual-plane laser, you can just program the slope you need, say 2.0%, directly into the machine. The laser then tilts the entire invisible ceiling for you. It actually creates a sloped plane of light. This is an absolute game changer. It means you can check your grade anywhere on the site instantly with just one rod reading. So, let's bring this all together. What's the essential workflow that the Excavation Academy calls their Academy standard for engineering the ground? It really just boils down to these 5 steps. 1. Find your permanent save point, the benchmark. 2. Use it to calculate your height of instrument. 3. Respect that HI. It's your single source of truth. 4. Do the simple subtraction to find your target depths. And 5. For drainage, let the modern slope lasers do the hard work for you. It's a simple, elegant, and incredibly powerful system. So the next time you see a construction site, you'll know about the incredible precision that has to happen before a single foundation ever gets bored. It all starts with that invisible line in the sky. Once the ground is perfectly engineered, the real question is, what gets built on top of that perfect foundation?